Second one, first today I will check the preliminary concept. Okay, before we start our original syllabus. Okay, what we have to study in this semester. Okay, so what is function? I will not ask any roll number. Okay, na? Anyone can answer. No need to search anything. Okay, you just reply what is function, what you know about function, not definition. So no one is knowing function. So I will start from function, correct? That is the problem of online classes. Okay. You know what is function, but you are not responding. What is function?
Dependent and independent variables.
No, when one fellow is unmute, okay, you should remain muted mode. Okay. Some Sanjay Reddy, actually, roll number 44. You only started, okay? First. So what is,
yes, sir.
Yeah, Sanjay, what is function?
The function is a relationship between a dependent variable and an independent variable, sir.
Okay. There is no relation between two dependent variables or two independent variables. Achha,
Sir,
just
two variables
tell
are
me.
independent, then
Okay.
there will be no relation.
What is relation between you and me?
Teacher and student, sir.
Who is independent and who is dependent?
You are independent and we are dependent, sir.
Oh. Is it good? Okay. Always you need one independent and one dependent function. Sorry, variables. Oh, very good. That is the basic concept actually. Okay, now. So, if you say forget about dependent and independent, one relation you can define as a function. So, like teacher and student, okay, and even parents and child, okay, now there is a relation. That relation is known as a function. Mathematically, you have studied the relation between two sets. That is called a function, okay, and that is function means a relation. Okay. So no, always you no need to give one particular definition, whatever you have studied actually in your class book or class note or notebook. Okay, sorry, that book. Okay, immediately you answer what you know actually regarding that. Okay, basic concept. Okay, so that is function. So have you gone through your syllabus? I will share your syllabus now with you. Okay. The window first. Okay. This is the syllabus. Transform and complex analysis. Okay. You have a 3 credit course, this one. So 300, no lab, no tutorial. Okay. But if we need, we can add one tutorial. Okay. You have a lot of actually empty period. I have already noted down that one. Okay. So transformation and complex analysis. Have you studied anything regarding transformation earlier? Which semester you have studied, if you have studied, or which class? You have not studied earlier.
Sir, last semester we studied Fourier transformation.
Fourier transformation.
Good, very good. Fourier transformation you have already studied. Okay. So now this time Laplace transformation, correct? So is it this 2 to 1 only? Na? We are going to study. So what is Fourier transform? don't give me the
To get a function in
definition.
form of summations.
Okay. So Laplace transform, what actually we are doing in Laplace transform? One function we can write in the terms of, okay, series, correct? Summation form. Summation form means in series, correct? So, okay, so that's why I asked what is function. So, and can you know the nature of the function for the Fourier series? You have studied already, no? So, what is the nature of that function? Actually, based on that, you can do the Fourier transform for that one. Try to answer, no problem. Okay, if you are not able to answer, it's not a problem. But if your answer is wrong, also no problem. You can try basically. What is that one?
Piecewise smooth, sir.
Correct. Okay. So, have you heard periodic function?
Yes,
What
sir.
What
Yes,
is
sir.
periodic function?
Yes, sir.
They repeat in intervals of time.
So that means actually, if you think about the figure or diagram, okay, after some times it will be like same diagram, okay, repeating the same diagram or plotted, correct? So what is actually your in your subject, that is you are student of electronics, correct? ECE, okay. Can you give one example of a function which is periodic function? Which is most
Sine
sine function you are using? Sine and cosine function, both, okay, na? Correct. So these two. Is it f of x, tan of x, okay, tangent of x? Is it periodic function or not?
Yes, sir, it is.
Yes, sir.
Periodic function. Okay. Are you sure?
Yes, sir, tan is periodic.
Okay, periodic function. What is the, okay, periodic function? Have you heard other period? Okay, so what is the t time period for that? Means tangent tan of x. Pi.
pi.
What is the period for the function f of x equals to sine x?
2 pi, sir.
2 pi, sir.
Okay, very good, very good. So now you have actually in unit 1 we have to study Laplace transform. Okay, Laplace transform and Fourier transform. Okay, you can by suitable changes you can write Laplace transform into a Fourier transform also. That one I will show you later on. Okay. So just see, but in the case of Laplace transform, if you see the second line of unit 1, the Laplace transform, is it visible my that PDF file?
Yes, sir.
Yes, sir.
Yes, sir.
Laplace transform of unit step function, impulsive functions, and periodic functions, convolution theory. That means in this case the function may no need to be a periodic function. Why? Impulsive function, periodic function, correct? No? But Laplace Fourier transform, the function should be a periodic function. Clear? So next one is, what is the similarity between Laplace transform and Fourier transform? Both the transform for the continuous function. Okay, but maybe, okay, you can find the both the transformations for the case of finite discontinuity function. What is the meaning finite discontinuity function? I have a specific number of points. Okay, so not in infinite number of points. So if your function is defined between a to b, okay, if at one point c lies between a and b, okay, lies between a and b, then you can say that the function is discontinuous at c, and it is a only one point the function is discontinuous. That means finite number of discontinuity. In such cases also you can find the transformations. Okay, and yeah. Yes, yes. Uh, uh, mm. No. Actually, at point only, at that point. Okay, why? If you see, okay, if the function is discontinuous at a point and there is no other point surrounding that, it's a very small surrounding. Okay, now that is called epsilon radius. Okay, then it is discontinuous function, but at a particular point, not for that. You can't say that discontinuous for all the points, only at that particular point. Okay, that is the actually why I told you the finite discontinuity. If you have only one point, if you add 0, say 0 plus, so you have a concept now, 0 plus, what is that? It's not a 0, but very close to 0. 0 minus, you have already studied limit extends to 0 minus and limit extends to 0 plus, correct? To check the continuity. So that point, even if it is very close to 0, if that point function is continuous, then you can say that it is only at 0 it is discontinuous. Okay, but some function is there actually so many points it is not continuous. Okay, so that is infinite number of discontinuity. Such cases we will not discuss. We can actually consider the transformation of such cases. Okay. Regarding 10 function, you can check. Okay. Actually, I told yes, but you can check the function is periodic or not, at what point it is discontinuous. Okay, clearly. Okay. Next, unit 2. Unit 2 is the applications of Laplace transform. So basically, first unit 1 is the definitions and the properties and Laplace transforms of different functions. Okay, and additional part is convolution theorem is there. That means product or arithmetic operations of two functions. What will be the Laplace transform of that function? I think convolution theory you have already studied for the Fourier transform, correct? So same, actually not same exactly. You for the transformation of Laplace, you have to study the convolution theorem. So the convolution theorem is included in your syllabus for the case of Laplace transforms also. Have you studied convolution theory for Fourier series transformation or not?
No, sir.
No, sir.
No, it should be there. Okay, let it. Convolution theorem, that is different actually. Here it is different, but convolution theorem for Laplace transform also exists. Okay. Okay. So I don't know why you have not studied. Maybe it is there, or maybe due to some other reason. Unit 2. Unit 2 is the applications of ordinary differential equations. What is the meaning of why you have to study the unit 2? So you already know, okay, how to solve ordinary differential equation, ODE. Am I correct? Have you studied the solution procedure of ordinary differential equation? I think in 12th standard itself you have studied, correct? That's it. Then why you have to solve the ordinary differential equation using transformation? Okay, so sometimes really it is not able to solve using the conditions given for the differential equation, ordinary differential equations, but using the Laplace transform easily you can solve that one. We will give the details concept of the ordinary differential equation solution using Laplace transform during that time only. Now unit 3. Okay, unit 3 is Z transformation. So far you have studied Laplace transformation and Fourier transformations. Okay, now just now we have not studied now, but both the transformations actually the domain is continuous. That means a function. Okay, a functions, that means a continuous function. Now Z transform actually is a transform, okay, to handle the discrete functions. Okay, so discrete function, what is the difference between continuous function and discrete function? Function and discrete function also. Can you give one example of discrete function? Discrete case, this one actually we can say that. So discrete case means when your domain is an integer. Okay, now say 1, 2, 3, 4, 5. Can you give one example whose domain is 1, 2, 3, 4, 5 natural numbers or 0 including? Okay, you have studied in first semester, that one I know. What is that? I have not taken. Okay, somebody else taken that one. Okay. What is that one? Whose domain is 1, 2, 3, 4, 5? What is that function? If you just try to answer it, okay. If it is wrong, also no problem. But if you are silent, that is different. That means you have not studied. Okay. Have you studied sequence? What is sequence? Sequence series you have studied or not?
Yes, sir. We studied, sir.
So then series sequence you have already studied, then you are silent only. What is the sequence? What is sequence? F of x equals to? What is x? N, na? F of n or u of n, correct? Or un equals to 1 by n. What is that? Series, correct? But if you add, then only series. If you add summation of un. Okay, what just wait, I will share. Am I able to share or not? Okay. Okay, I will show. Then actually now I'm going to write. So it will be easy for you. Okay. Just 1 minute. Again, I'm sharing one more window. Is it visible? Black screen. Now, just wait. Now it is black only. Black till now it's not visible, correct? I will, yeah, yes, I will check. What is the status? Is it black?
Black screen, sir.
Okay. So now, so there is no chance I have to change it. Okay. Tell me now. Black. Actually, window. Whole screen. Okay, okay. Again. Okay, okay. Okay, okay, okay. I will start again. Okay, presenting again. Full screen I will see. Okay, now. Tell me. What you are? What I have? What it is written here? Good. Okay. Now it is okay. Next. Okay. So see. UN, you have studied UN, correct? Equals to 1 by n. What is this? This one you have studied like that, UN. Okay. What is that one? It's a sequence. When n actually belongs to, okay, what is that? N is natural numbers including 0, but here it is 0 is not defined 1 by 0. So it is starting, here it is n equals to 1, 2, and so on. Okay. This one. Okay, so this and so on. So this is called a function, but one particular name is there, that is called sequence, correct? 1 by n. Okay, if you add that one, that means un equals to 1 by 2, 1 by 3, and so on, correct? What is the domain of this function? This function domain is this one. Okay, so 1, 2, and n. So there so many points are there between 1 and 2. So this is actually discrete points are taking as the domain. That means n equals to 1, n not equals to, sorry, n equals to 1, and n equals to 2, and so on. So that's why it is called. But if you write, okay, f of x equals to 1 by x, what is this then now? F of x equals to 1 by x. This is a function. Okay, when if you you are writing x belongs to, so 1 not 0, so you have to write like that, 0 comma infinity, correct? So this one, or you can write x belongs to 0 comma 15, correct? Then this is a function and it is a continuous function. This one is a discrete function. Now you have studied the transformation or the series, okay, of a function f of x using two concept a transformation, that is one is Laplace transform, sorry, Fourier transform. You have already studied that one. This semester you are going to study the Laplace transform, correct? But this type of function, that is discrete case, okay, you are going to actually learn that one is called Z transformation. Clear? That is called Z transformation. So discrete case Z transformation. Okay, now actually just 1 minute. Any changes? But any changes? Are you able to see the same screen or different?
Sir, we are now seeing new page, sir.
Okay, good. That's good. That means it is working now. Okay, then unit 4. Okay, unit 4. What is that one? Unit 4 is complex. Okay, unit 4. Okay, that is actually complex variable. Okay, complex variable. You have studied till now the function f of x, where x is a real line, x is the variable. Okay, that is called minus infinity to infinity. Okay, so that case actually the it is called a real function. Okay, you have already studied this one, but now unit 4 you have to study the complex variables or complex function. Okay, what is complex number? You have studied that one, I know. Okay, you told I have written immediately. Okay, now you have seen z equals to x plus iy. You have this, so this is actually what? Real part, and y is imaginary part. Correct? Since it is I is multiplied. So since if you write this one in the form of the two-dimensional, okay, na, R2. So it is x comma y. Y is real, but since it is actually associated with I, that's why it is called imaginary part. Okay, and x comma y is the code that notation form of this one. So it is not like only x; it is x comma y. So actually, what you can see from that one, okay. So you can see that next one is, so anyone, if you can write, sorry, x and y. So any point, say this one, x comma y. So this is the point you are writing. So one is imaginary part and one is real part. So this is case z, x equals to iy. Okay. Sorry, you are joining from 0 comma 0, so it is 0 to x I x comma I. So this is the position of that point z. Okay, if you graphically x plus iy. Okay, now till now you have studied only the real function x as a variable. Now the function you have to find f of z, where z is a complex number. That means it is the z has taken from the domain. It is called a complex domain. That means these are the point where you can take negative also, no problem. Okay, so these are the point where z you can take, and you can construct a function f of z. Okay, that function is called complex function. Okay, the domain is the complex number x plus iy. Okay, but if I write y equals to 0, now z equals to x, is it complex or real? Quick answer. I told you don't take much time. Okay, now? Yes or no? Is it complex or not?
Complex, sir.
Yeah, good. Since we are discussing in complex domain only, then also z equals to x is a complex. Okay, what is the meaning of that? Is the imaginary part is 0. Clear? So that is the case. But it is so what is that point? That point is here. Okay, that point is here. This is x comma 0. Okay, but it is in the organ diagram. That is organ diagram. It is called complex domain. Okay, so unit 4 and 5 totally actually complex variables. Okay, and everything you can't write in your from your engineering problems. Okay, if you discuss regarding engineering problems, you can't write everything in the real domain. Okay, sometimes, okay, maximum times you have to better to represent in two-dimensional, that is the complex domain. So you have to study in details complex variables, complex functions, and their natures. Nature, what is the meaning of nature? Functions nature you have studied, no? Continuity, differentiability. Then can you remember, you have studied f of x first, function, then continuity of that function, then differentiability, then you have studied integration, correct? After that you have studied, before that differentiation, then integration, then differential equations, and that is. So here also you have to study complex function, then continuity. Continuity means discontinuity is also included, and then differentiation, then integration, and differentiation and then integration, but not a differential equation. Okay, up to that one. And just a few minutes back, actually, we have discussed Laplace transform. Okay, so and you have already studied Fourier transform and Fourier series. Here also complex functions also you have to write in terms of series. So since the complex domain is z equals to x, plus iy, either in terms of z or both x and y, you can define the series in complex domain, both either in x and y terms or only z terms. So if I say the one series, okay, so if I say one series, okay, f of z, okay, 1 plus 1 by z plus 1 by z square, it should be small, plus 1 by z cube and so on. So what is this? This is a function. Okay, this is a function. Okay, is written in the form of series or summation form. So f of it is, you can say f of z equals to summation 1 by z, okay, power n equals to 0 to infinity. Correct. So this is the series, complex series. So you can write. We will discuss this one in unit 5 in details. Okay. So this one is the preliminary concept of that one. Okay. All this, sorry, of all the full syllabus discussion. Okay. Basic concept or basic topics you have to cover. Okay. During your this semester mathematics MM. Okay. M221. Okay. Now, okay, we'll start little bit today. Okay, regarding the Laplace transformation. Okay, then we will complete. I will stop today. Right after that, in details, we will start tomorrow. Okay, I think we don't have tomorrow. Day after tomorrow. Okay, I will. Can you help me to write new page? Fourier transform. Only so basic concept I will not give you today. Only the difference. Fourier transform. Okay. Fourier transform. What is the actually form of the Fourier transform? Definition now. So Fourier transform. I'm writing. If I am wrong, okay, you can inform me. Fourier transform of any, say, f of p. So the function is f of x. We are transforming Fourier transform, okay, to capital F of p. So x is the original function variable, p is the transform variable. F of x, Fourier transform of f of x. Okay, so that is, you can write, so many notation are there. Capital Fourier transform of, okay, capital small f of x. Okay, so what is that one? If I write minus infinity to infinity, 0 to infinity, okay, small f of x e to the power I p x, okay, dp. This is the Fourier transform, correct?
Yes, sir.
No, sir. This is not. I have written intentionally something wrong.
Yes, sir. Minus infinity to infinity it should be, sir.
But no problem. You have started. That is good immediately. So just check it. No problem. What are the mistakes? First mistakes I will write. What are the first mistakes? What are the mistakes? Okay, now. So tell me the changes.
Minus infinity instead of 0, sir.
Okay, that is, I have already rounded the mistakes. Okay. So
So
tell me.
then instead of dt we have to write dx.
Very good. Okay, some books are using, I am changing. Okay, now that is that your correct answer is correct now. Okay, now. No problem. That's good. Very good. Only one changes some definition. They are write this one minus ipx dx. Okay. If you write here negative, then the inverse transform should be positive plus ipx dx. Okay. If you not write here negative, means ipx dx. So I will change now. Okay. If I change your so this one correct now. If I change, then the answer is like that, integration, okay, minus infinity to infinity dx, correct? So if this is the Fourier transform, the inverse transform is f of x, that is Fourier minus of minus of capital F of P. Okay. So in that case, actually, 1 by 2 square minus infinity to infinity. Infinity F of P e to the power minus I P x now dt. So here minus, here it is minus. But in case of you have written here positive, negative, then it should be positive. Now Fourier transform you have seen. Now I will change it and I will go in the case. Now the Laplace transform. What will be the difference? Then I will go to the black then I will have the difference between them. Now it is Laplace transform. What is that function? Laplace transform is equal to Laplace transform of the function f of t. Actually, there is a no problem. So 0 to infinity, I might like to the power minus I. I. The Laplace transform x. F of x. Dx. So it will be t instead of t. So it should be t only here of and dt. So from the right hand side transformation, you can see that since you are integrating to t and s is there. So it will be like a function capital F of s. So that is we will write like that not capital F of s. We will write capital L. Capital L of s. Or something, no problem. Capital L of s. That one. So what is the difference between this Laplace transform and Fourier transform? What is the differences between Laplace transform and Fourier transform? Tell me. Yeah. So both Laplace transform from positive, correct, 0 to infinity. But Fourier transform you can define from negative. One more difference there. What is that one? Can I will go to the previous one. This one and this one. Yeah, to the minus. No, that is here is the original of P. Somebody actually is one sorry, to the power I here it is, and to the power minus I. Correct, IP. And then so that it is called kernel. AERNEL. Clear? So kernel is different. Here it is kernel is e to the power minus. Sorry, e to the power minus. Oh, I have written wrong. One more difference is there. Sorry. Yeah. Now one more difference. What is that one? Here e to the power st. E to the power minus st. Not in complex domain. Correct. Here it is reverse. Here it is just the IP. Correct. It is complex domain. Clear? So next. So these three are the differences. So here e to the power minus st is the kernel of the transformation. So kernel is also different. And the function f of t should define from 0 to infinity. That means in positive range. So if you now from this definition or from these notations, you can, if you draw some conclusion, then we can say that first one is What is the function? What will be the then function? The function should be defined from 0 to infinity. Earlier one minus infinity to infinity. Okay, and of course the function should be continuous function. Okay, and since you can see that 0 to infinity, okay, the integration range is 0 to infinity. So the infinity. So what type of integration this one? I will. It is defined integration. Okay, sorry, finite integration. What is that one? What type? You have studied maybe.
Definite.
Definite, of course. When the limit is infinity, then it is called something that is called improper integration. Okay, you have to find the integration for this type of function. Okay, this type of function e to the power minus st into f of t. Okay, so some rules are there. If it is simply you can find the integration, it's okay. If it is not possible, then you have to think of how to use that one. Some concept you have to apply. Okay, so this is the definition of Laplace transform. Actually, just for difference between earlier study and this study we have discussed. Okay, so now Laplace, what is the meaning of the Laplace transform? Okay, why you have to study this one? Okay, so now this function f of s, actually this function, it will surprise if it is no negative, sorry, I, then also this f of s is called the complex domain or complex frequency domain. Okay, or sometimes you can simply say the frequency domain. Okay, so now what is the concept of this one? I am not giving any definition. I am giving you the concept, how to think this one. So f of t using Laplace transform, okay, you are getting f of s. Okay, so t is the time and f is the complex. Okay, so from time domain to, or you can say the frequency. Okay, now complex f of x, so it is frequency, you can say that. Okay, so from time domain to frequency domain, it is changing. Actually, that is called Laplace transform. I'll say you once again. Okay. So what is the meaning? From this transformation, what they are doing actually, time domain to frequency domain. Okay, so that is actually, you sometimes you need actually, you not able to solve, okay, directly using the time domain, then you change it to frequency domain. Since you are changing from time domain to frequency domain, but your original problem is in the time domain, then what you have to do, you have already did that on the earlier study. What you have to do then again? So you just see the arrow from time domain to frequency domain, but your answer, your function is in the time domain. What you have to do? You have to change it. Okay, after solving, you have to change it again to the time domain. After solving, that is called, what is that called? What is this change now? From f of t to f of s, sorry, capital F of s. Now what you have to do to get the original solution in the time domain? Then you have to take inverse transform. Okay, inverse Laplace transform to get the solution in the form of time domain. Okay. Okay, that one details, definitions and etc. we will discuss in the next class. Before that, okay, I have some questions. Have you studied, okay, some particular type of function, Heaviside function? If anyone knowing that one, you can answer, no problem. Okay, some particular type of function will define first, or we will check it today for discussion. Okay, have you studied this one? You have to study this one. Okay, why? Unit. Okay, before that, first one is, okay, sorry, unit step function. Somebody should discuss this one. Okay, you can say, I will write. What is unit step function? You have time, no problem.
Sir, is it a step function that increases by 1?
Okay, tell me the function mathematically. Very good. Can you answer? Take time, no
Yes, sir.
problem.
F of x is equals to step x.
F of x equals to, what is that one?
Step x, flower bracket of x.
Power bracket of x, this one. Okay.
Yes, sir.
Can you elaborate a little bit to your friends so that it will be clear for them?
So, sir, it is square bracket, sir.
Oh. Good. So, am I right now?
Yes, sir.
Okay. Little bit, can you discuss that regarding that function? No problem. If you just tell me, I will write. What is that function? Better to discuss now so that it will be easy for you people. What is the step, unit step function? In your syllabus, it is
Greatest
written.
integer function.
Huh?
Greatest integer function.
Okay. No, say what is the x domain? Can you say the x? What is x? Then it will be very
It is defined for all values of x, sir.
all values of x. Any point is means you have to discuss.
Sir?
Any point you have to discuss, or for all values of x?
For all values of x, it is defined, sir.
Okay. If x equals to 5.34, what is
Then
the
it's 5,
function
sir.
value? Huh?
5. Function value is 5, sir.
So function value is f of x equals to 5. That's why actually that type of way you have to discuss. So if it is x equals to, I will write, okay, now 2.91. What is the f of x?
2, sir.
So that is confusing. But what is your answer, bhai? Tell me once again.
2, sir. Answer is 2, sir.
Answer is 2. Okay. But your friend actually having some doubt if it is near to 3, why you are taking 2, correct? Somebody told actually. Yeah. Correct. So, yeah. 2, okay. Understood. So this one. So this is the basic concept of, we will discuss in details again how to take the Laplace transform of that type of function, unit step function, during that time. Okay. Now, next part is, you know the periodic function. It is there, correct now? What is periodic function? You have already studied that one. Okay.
Yes, sir.
So periodic function f of x, any function f of x equals to that one, and then you will just tell me what is the period of that function f of x. Correct. F of x equals to periodic function sine of x. Correct. Sine of x. So this is the function. What is the period of that one? 2 pi. Correct now. So after 2 pi, sine 0 0. Okay, sine 0 0. So it is x. Okay, it is f of x 0. These are the periodic function. My drawing, if it is not correct, also you have to consider it is correct only. Okay, now 0. This one is what?
Pi, sir.
Pi. Very good. This one is twice pi. Correct now. So you just see, if you consider this one, okay, same figure is coming. If it is drawing is not same, then also you have to consider it is the same drawing. Correct. So this is the function having 2 pi as a period, and the function is called periodic function. Okay. What is impulsive function? Next one is.
No particular period, sir.
Okay. That's what. Next one is impulsive function. Okay. impulse function. So these three function actually it is written in your syllabus. So minimum these three function you have to study. Okay, additional some functions also you can study, but minimum that one. What is that one? Tell me and someone and then explain it why it is called impulsive function. Using one example also okay for me, no problem. So that your other friends also can easily understood what is the impulsive function.
It has great change of y for short x.
Okay. So one function and having power.
Powers, yes, sir.
So can I write x to the power n?
Yes, sir.
Okay. So such type of function. Then almost all function actually included. So if you say periodic function, then sin x cos x, correct? If you say unit step function like that, what you have discussed, and if you say impulsive function, the power function, okay, x square, x cube, and so on, correct? Na? E to the power x also like that. E to the power x or x to the power n like that. Okay, this type of function. So minimum this type of function, other function also we have to consider. So the next class, okay, using definitions of Laplace transform and their properties, we will start. Okay, clear?
Thank you, sir.
Okay. So next class is on I think Friday, na? That is on 6th. Okay. Today is 4th. Okay. So that's all. If you have any doubt, okay, we have not discussed today in details anything. Only preliminary concept only we have discussed. So if you have any doubt, you can ask me. Okay. And every day I will give some assignment. Okay, that means okay. Sorry, not assignment. Class homework. Okay. So I will not give you any assignment. So you know that you have the breakup of marks like that 20, 20, 10, and 50. Correct. Total 100.
Yes, sir.
So out of 20, 20, that means that 2 is the cycle test as it is. Okay, we will discuss how to conduct that one. Okay, depends on us only. But the case of 10, mark 10, that is assignment. I will not give you any assignment so that you can copy paste and you can send to me. Okay, na? Unnecessary. Correct. Is it?
Yes.
Are you doing like that only or not?
Yes.
No, sir.
No, sir, we are doing our own.
So only 2 fellow are saying no. So that means these 2 are isolated. I think isolated fellow. Okay, now people are not taking them in their group.
No, sir. We have friends, sir.
Very good friends. So you have also chat box, correct now? So easily you can means not only you. You means actually now don't take you means you personally. Okay, now. It is actually now online classes is going on like that. You will be not believe actually what is the change, what is the answer actually somebody have noticed. Okay, say Fourier transform, what you have considered, S or P, what notation? P. Okay, now what happened, you know, one fellow share Fourier transform, his P is looks like 5, correct? So his P is looks like 5. So next fellow, okay, they have written clearly f of 5 and did all this copy paste and then sent to the faculty. Clear? So that is the scenario. Have you understood what I told actually?
Yeah,
One fellow
okay.
instead of f of 5, his 5 P is almost looks like means actually 5. Then next fellow who got that one, that chat in that chat box, he has written f of 5 clearly. He again shared to the other fellow. They also clearly written f of 5 and submitted that papers to the corresponding faculty. Now you just think what is that? Okay, even they don't know what is the notation. But if it is knowing also, they don't have time to think regarding that. Okay. So don't do that one. I will give you some homework. Okay. So, and individually, okay, so not for everyone for every day, okay, na? And try to complete by yourself and send to me. You should be ethically correct, but you are engineer, okay, so you are going to be engineer, means almost second year, so half stage you are reaching now, okay, so ethically should be correct, okay, and you have to response, okay, in your in my class, okay, so don't keep silence, just means you just log in and keep the mobile somewhere in on the table, okay, or on the fridge or somewhere else, okay, na? You should be present always, okay, so that I can understood that you are learning something. That's all from my side, okay. Okay, then, so 2 cycle test as usual, but there is no assignment. Assignment will be okay based on the class, or sorry, homework, and I will take 2 surprise test. Okay, I will not say you which date actually I am going to take, okay, and 2 surprise test, maybe 1 question, okay, for that particular day, okay, now. So based on these 2 homework and this surprise test, I will give you the marks of 10. Rest cycle test 1 and 2, it will be decided by you people, and I will agree with that one, and that one I will convey to your HOD. Okay, that's what we are going to do. But semester as usual, we don't know it will be online or offline. Maybe let you consider it is offline only. Sorry, online only. Okay, and we will decide that one later on. Okay, that's all regarding your syllabus and your pattern of the assessment and so on. So that's all from today. It is already 3:29. So we'll meet again in the next class with in details our syllabus. Okay. Okay then.
Thank you, sir.
Okay, thank you. You can leave the meeting now.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, beta. You should respond like that only. Okay, now. Not only at the end and beginning. Okay.